Okay, this is the lecture on expected value. It just basically builds upon what we've already done with conditional probability. The only major addition is the notion of utility, and then the notion of utilities with probabilities to give us our expected value equation. But the concepts are pretty much the same. So recall the definition of decision theory. This is from like the very beginning of the course. You guys probably don't remember it, but you might. Decision theory assigns probabilities to ideas or beliefs and utilities to values. So our beliefs or ideas are weighted in terms of how likely they're to occur. And then the things we value, we assign what are called utilities. One way in which we do this, the predominant way in which we do this in modern times is money, right? So things we value, we assign a monetary value. And then probabilities are assigned to other kinds of things, ideas, events, beliefs. Decision theory combines these things, but the notion of utility is far wider than just money. That MasterCard commercial, right? 20 bucks for a game with your son, $50 for a hot dog. I mean, that's ridiculous, but not really. You ever go to these games? It's kind of the prices are ridiculous. Watching so and so hit a home run, priceless, right? So the idea that there are things that outstrip money, that's the basic notion of values. Utilities are just ways to basically measure one thing being worth more than the other. And very often we're assigning that a numerical value, and that's best understood in terms of money, but got to keep in mind, money is not equivalent to value, okay? The notation to start off is that some action A you undertake has consequences. The consequences are denoted by C1 for consequence 1, C2, whatever, right? The value associated with those consequences are denoted in the following terms. Utility, this U is called the utility function. Utility of consequence 1, that's what it means to put it in parentheses. Utility of consequence 2, and so forth, right? So, for example, if you're betting and you place, let's say, 3 bets, the utility of your first bet is if you win. Utility of your second bet is also if you win, and so on and so forth. You can also measure differing consequences, like the utility of if your bet wins, and also the utility if your bet loses. The probabilities are conditional. They're the probability of consequence given your act, probability of the other consequence, consequence 2 given your act. They're just listed as, they get rid of the given because that's sort of taken for granted. So they just think probability of consequence 1, consequence 2, and so forth. Okay, with this notation, you get what's called the expected value. This is given by the following expression, exp parentheses a. So the expected value of some action A equals, basically the idea is the probabilities of the consequences combined with utilities of those consequences. So the probability of C1 times utility of C1 plus, probability of C2 times utility of C2 plus, etc., however many consequences and probabilities you're thinking about. What this gives you is a weighted average of these things together. Yeah? You can think more commonsensically. What this expression is telling you is that if you undertake some action, the expected value, what the calculation is giving you, is a weighted average of the pros and cons of that action. So the consequences are the pros and cons. The probability is the chances that those consequences come about. And then the expected value is giving you an overall summary of the pros and cons, saying whether or not this action is worth undertaking in the first place. Let's use a raffle example to help explain this. This will show up over and over again. This is like our urn with colored balls. This raffle example is sort of the basic problem, basic example for illustrating expected value. So suppose there's free tickets, free door prizes. The chance of each one is 1 out of 100. There are only 2 prizes to make it simple. One is a trip to Maui worth $100. The second place prize is worth $50. To sushi, well, you're not supposed to use real names, but if any of you have been to this place, it's got attitude. It's delicious, but attitude is free. Okay, so what's the expected value of the ticket? So the expected value, in this case, the action is buying the ticket, equals the probability of winning first place times the utility of getting that first place prize plus the probability of getting second place times the utility of getting the second place prize. So when you combine them together, the chances of winning that first place prize to Maui, 1 out of 100 times the amount it costs, $100. I just made it easy so the math works out. And then secondly, since each ticket has a 1 in 100 chance of winning, it's 1 out of 100 times the $50 gift certificate. When you add it up, it equals 150. So it's saying if you get a free ticket, you didn't pay anything, the expected value is that it's a $1.50 payoff overall. So it's on the plus side, it's worth it because it's basically only benefit. How much benefit? 150 on average. That's what this aggregate number means, basically. Now remember, you didn't pay anything for this, so the question is, what would be a fair price to pay for the ticket? $100? $10? $1? $5? Most people think, hey, you get a $100 gift certificate out there and then a $50. I pay $3. That sounds fair, not bad, right? Or someone else will say, nah, three's too much, I pay $2. Someone else says, nah, but you could win the $100. That's $5 is fair. Well, I mean, that's all intuitive estimating, guesstimating, really. But you want a more precise way to measure this? That's what fair price gives you. That's what expected value gives you. And by the way, I should mention this since it's coming up. In Vegas, do they give you fair odds? No, you just buy into it. Who's calculating those odds in the background? Well, somebody's doing it. They're not just making it up willy-nilly. Vegas is very precise. They're about profits, right? One of the ways in which they do this is using expected value type calculations and then jacking up the odds slightly. Not in your favor, in their favor. Fair price for X would be the average equaling 0. Why? Well, if your chance of losing X amount of money evens out with your chance of winning Y amount of money, the price you pay for the bet is fair. Not just for you, fair for you and fair for the other side, right? So, back to our example, what would be a fair price to pay for the raffle ticket? Well, suppose you pay only $1, right? Then the expected value of the ticket is the probability of winning the first plus the utility, which is to say the amount you win, but minus the $1 you pay, plus the probability of winning the second place prize times the utility of that, the sushi sasabune, the expensive sushi. $50 won't get you much, by the way, at that restaurant, minus the $1 you pay for this ticket, minus, this is the minus part. Why minus? Because if you don't win, you lose. You don't. In these two cases, if you win, you get the probability of the first is you win, right? You get money coming in. Whereas in this case, not winning means you lose. How much do you lose? Just the cost of the ticket, $1. So when you stick in the math, it's 1 out of 100 times $100 you win minus the dollar you paid, plus 1 out of 100 times the $50 minus the one that you paid, and then the remaining 98 slots. There's only 100 slots total, so 98 out of 100, and then the $1 you lose. When you do all this, it's 50 cents. 50 cents indicates that this is not fair. If you did this calculation correctly, this number should add up to 0. So that means someone is winning and someone on the other side is losing 50 cents on average. So what's the fair price? Well, we solved it before so that the expected value of the ticket equals 0. And when we said you didn't pay anything at the beginning, that ended up being 150. So it turns out 150 is the fair price for the ticket. Here's the general formula for calculating for the fair price for expected value. If you find that the expected value of something when you calculate it is X amount, and you pay Y amount for that, the fair price will be in this order, Y plus X. So, to use our example, we found that the expected value of something not paying at all is 150, and you pay $0 for that, right? In our first worked example. The fair price would then be Y0 plus X, 150. This will work out for other cases where you pay money because the Y plus X might be, one of them might be negative, one might be positive. You have to do it in this order, Y plus X. The amount you pay plus the expected value. It might not be addition, it might be subtraction. So you got to figure that out. It will vary, there will be problems like this. Okay, why expected value? Well, it's about taking calculated risks. It's not just the probabilities, and it's not just how much you win. People usually focus on, say, if you go to Vegas or they bet, they focus on how much they can win, the big jackpot. Other people, maybe more cautious, only focus on, well, it's unlikely. Why should I give my money and just throw it away? What expected value gives you is a more balanced, nuanced, more precise way to measure the risks as well as the pros and the expected payoffs or cost of money, let's say, or price paid whatever that price is, monetary or otherwise, right, of those consequences. So expected value is giving you a more nuanced way to calculate your risk. Logic, remember, is the art of, it's about the study of inferences. And if you think about it, it's really about the art of reasoning of whatever sort. And the more you acquire these tools of logic, you can stand on your own 2 feet and reason better, take better calculated risks, and in tandem with what this section's about, make hopefully better decisions. That's part of what decision theory is. It's a framework for hopefully making better decisions. It's not a guarantee, it's just a sort of guide. Okay? So that's the break for now, and we'll cover an example next time.